here. All right, here we go here. So it says, which of the following equivalent forms of the function f of x equals 4x squared plus 4x minus 24 is the most suitable to indicate the x coordinates of the x-intercepts of the graph of y equals f of x in the x, y plane? So they're basically asking for what's called factored form. And I wanted to use this problem to illustrate the things that you would do for factored form. So the first thing you would do is always look for a greatest common factor. Is there a greatest common factor that you see in here?
4.
4. So you take a 4 out of each of them. What would go inside parentheses when you divide each of these by 4?
X squared plus x minus 6.
Very good. Okay, now this is no better really than the previous one because you still don't know the x-intercepts because you don't know the factors. So that's where you got to factor again in this. This is the factoring a equals 1, 1 referring to the coefficient in front of x squared. So you're looking for two numbers that multiply to -6, but add to +1. Can you think of those two numbers?
-2 and +3.
So those add to, yes, x minus 2, x plus 3, those add to +1. Okay, now the reason this is most suitable is because you can read off the x coordinates from here. Now you're actually setting each of the factors equal to 0 to do that, if you recall. What are the two x-intercepts based on this?
+2 and -3.
Positive, -3, perfect. All right. So now let me give you another one like this to just work on the factoring part with the greatest common factor. So let me just pull up a problem or two. Excuse me. Okay, so let's say it looked like this. F of x equals 5x squared minus 20x minus 25. You want to first factor out the greatest common factor. What would that be in this problem?
5.
5. Yeah, so 5 goes on the outside, and then you're literally dividing each of these by 5. What goes inside parentheses?
X squared minus 4x minus 5.
Good. So now you want two numbers that multiply to -5, but add to -4.
2, -5. -4 and oh wait. -5 and +1.
Yes. Now, can you tell me the two x-intercepts?
+5 and -1.
Yes, very good. All right, let me have you try one more here, start to finish. Let me grab it here. So the little wrinkle I'll throw into this one is that the greatest common factor can be negative. So let's say it's -3x squared minus 6x plus 45. The greatest common factor is -3. So I want you to try this one, and I just want the two x-intercepts. And then we'll move on to a new question or new topic after this. Do you have any questions on this one?
Not so far. The x-intercepts are -5 and +3.
I moved away from that. You said yes, those are correct. Okay, very good. All right, so let's look at another question here. I'm not going to snip in the answers because it kind of gives it away, but I want you to read it and try to tell me what you think it's asking for. We're in the same topic area though, so it's hopefully that is a good big enough hint for it. So go ahead and read this problem and let me know what you think it's asking for. What do you think? What is this asking for here? This is key right here.
So the equation that shows the x-intercepts as constants or coefficients.
Right, but what have we been doing the last couple of problems? Like what have we been doing to get to this line?
Oh, finding the greatest common factor, factored form.
Factoring, yeah, factored form. So that's what this is asking for. It's saying write this equation in factored form. And that's what you need to think of x-intercepts. You need to think of, oh, that's factored form. So let me snip in the answers and maybe it'll be more clear. I was trying, I wanted you to kind of make that leap here and not just give me the answer, but understand why. So look at these 4 answers here. Are any of them in factored form?
Letter D.
Yeah, that's the only one. So factored form is really useful for finding the x-intercepts.
Okay.
All right, now we'll look at this next problem together. We'll just talk about it. Okay, here we go. All right, so when you look at this problem, what form is it in at the top here? What form is this in?
Um,
What form was this one in up above here?
oh, factored form. Okay.
Yes. So it actually doesn't matter how many factors it has. If it's in this form, it's in factored form.
Okay.
Can you tell me the x-intercepts? I know it's not asking for that, but could you tell me those from this?
+1, -1, and -2.
Good. All right. So the this is this is a different question, but I mean that's a little bit odd, I guess, how it's asking, because it's a not question and they're giving you something else. So we'll just kind of decode it together. It says the graph in the xy plane of the equation above contains the point A, comma B. A
Mhm.
comma B. All right. So like what does that mean? It means like it's an XY pair. It really is an XY pair, but they're trying to help you out. They're saying like, well, A could be anything from -1 to 1. So let's just say for a moment that A is -1 and A is really the X value. So
Mhm.
when X is -1, what is the Y value?
0.
Why is it 0? When it comes from what we just did before. What does the factored form tell you?
Um,
And you just wrote it down here.
it's just the x-intercepts.
Yes, it's where it crosses the x-axis, which is
Okay.
which means y is 0. So what about when x is 1? What is y?
Um,
What do you know about x equals 1?
that's that's where it crosses.
Yes. So what it's an x-intercept. So what is the y value at the x-intercept? When it crosses the
0.
0. Yeah.
Okay.
Okay. So that's kind of important. It's kind of like saying like on the graph here, there's 2 points and they're both 0 at -1 and 1. Like actually let me move that over a little bit. So the question is, what happens between them? Like, does it go up or does it go down? And it reasonable would be like, well, I don't know how to do that, Matthew. Like that's impossible. We do know what happens at 0 when x is 0,
Mhm.
because we can plug that value into the equation. Do you see that? Like you can actually get a number out when x is 0. 0
Mhm.
minus 1 times 0 plus 1 times 0 plus 2. What does
Okay.
that become?
-2.
Yes. So that means it's actually this bottom one. So that means the graph traverses this bottom position.
Okay.
Okay. So and we've already indicated that it could be 0, so 0's out. But since it could be a negative number, leaving D as the only one there.
Okay.
But the thing I want you to keep taking away from this discussion right now is factored form gives you the x-intercepts. X-intercepts means that y is 0.
Okay.
Okay, so let's look at a new problem. All right, so when you look at this question, when you look at the part that I'm boxing in, I want you to tell me in your own words what is different about that compared to some of the other problems we've been looking at tonight. What do you see that's different about this one?
It's factored form at the top,
And on the
but
bottom?
on the bottom there's only x.
There, yeah, so we're not used to seeing anything on the bottom.
Yeah.
So what if I told you that you could treat this like this? You could ignore the bottom. How would you answer this question?
So would you just solve it the same way, like how we have been?
Yeah, I'm really just asking you, like, what are the x-intercepts of this factored form?
-3 and +2. So option 1 and 2.
Okay, so what letter would you choose?
1 and 2, letter C.
Yes. So this is another strategy. It's the kind of strategy where you got to be, always like everything else, you got to be really careful, but you can sort of just say, well, what if like I ignore the part that I don't really like? I mean, it doesn't work for everything, but it does for this one. And like the intention here is to be very distracting, to be like, okay, student will just say, I have no idea how to do this, and then but they actually do. All right, so just keep that in mind here as something going forward.
Okay.
So let's do one more before we switch topics here. At least one more here. All right, so I'll read this one out loud. It says the function f is defined by a polynomial. Could be a quadratic, could be a cubic, we don't know, don't care. Some values of x and f of x are shown in the table above, okay? Which of the following must be a factor of f of x? So we've talked about this table method before. On the left here is the factor. What is the x-intercept that corresponds to each of these on the right?
Is A +2?
Yes.
Okay.
And B?
3, C is 4, and then D is 5.
Okay, so now look at this table and decide which has an x-intercept that matches, or figure out where the x-intercept is on this table and match it up with the factor on the right.
Letter C.
Yes. I found one more that we can do that's like this, which is good. All right, go ahead and take a look at this question and see what you come up with, please.
Is it letter C?
Yes. Very good. Okay, I found one more. This is a good one for us to do. I'm going to do it in pieces though, so it doesn't overwhelm with trying to figure out what to do. So when you look at this equation, could you give me the 3 x-intercepts to this?
4 -2 and 1.
Okay. Now, x-intercepts also means, we've also talked about this idea of factors, which they're related, right? If you go back to this one with the table, the factor is x minus 2, but the x-intercept is 2. The x-intercept is another word for solution. Okay, so like it's like you cannot interchange all the words, but x-intercept means solution. All right, now I'll put in the rest of the question here. So like, why is he saying that? Well, here we go. What is the product of the solutions to the given equation?
Letter D.
Yes, very good. Okay, so we did some parabola stuff here. Let's see what else we can do with parabolas. Quadratics. Do something with quadratic formula here. I don't think we've done this much. So we'll just start with a basic, like, do you remember the quadratic formula type question? Because I don't think it's given as a formula. Okay, do you remember could you tell me the quadratic formula right now? I know I'm putting you on the spot. I'll start. Oh, it's like Wheel of Fortune where they start showing the letters. I don't know if you've watched that.
Oh, it's like negative.
Negative e plus or minus. Square root. Do you remember anything else here? Okay. So you do have to remember this. Yeah, I can't give you any motivation other than you got to know what to do it on the test. It's not like it's, for your driving test or something. It's just a formula you got to know. What is the value of A, B, and C in this problem up here? So it's ax squared plus bx plus c. That's the standard form.
Okay, so A is 3, B is -7,
Good.
and C is -1.
Perfect. Okay. Now I'm gonna reframe the question. Keep those numbers in mind because it's always good to look at the answers. Okay. And in this problem, let me get this snipped in. The answers. Like you're gonna see here. So when you look at the answers, I look at A and C as having the square root of 37 and B and D having the square root of 61. So that's your differentiator. Like you're not doing the quadratic formula. You need to do it in pieces. Like you want B squared minus 4AC. And you just told me that A is 3, B is -7, and C is -1. Now, I've been showing this differently now to students. I'm showing it now with the parentheses around the letters because that's how you want to substitute this in. You want to go -7 squared minus 4 times 3 times -1. So we need to get it down to either A and C or B and D, and that comes from the discriminant. So could you calculate that for us?
Um, 51.
51 is not an option. you gotta give us one that's an option here. So 49. Because that'll really frustrate you on the test. You're like, why isn't it there?
Yeah.
I was working with a student earlier and I kept giving the wrong answer. And I was like, it's very frustrating because I know it's got to be there. Is it minus 12 or plus 12? Because
Plus 12.
it's plus 12. Yeah. So that means it's 61. So that gets rid of
Oh, okay.
those two. So remember, the formula is minus b plus or minus. Does that mean it's letter B is your answer or D is your answer, with your B value being minus 7?
Letter D.
So you're negating the negative 7.
Oh,
That's
okay.
what it means there. So that's positive 7. Positive 7. Is that okay?
Yeah.
We're gonna do another one like it, but I need to just ask if you need any clarity on anything. All right, so I want you to calculate the discriminant, the b squared minus 4ac. And again, I kind of prefer the letters to be in parentheses now to make it clear that you're substituting those in. So this one has no negative signs, so it should be a little better. No chance for a sign error in this one.
Okay. Is it 20?
So your b is 6 squared, right? Minus 4 times 1. So yes, it is 20. Very good. So like all the problems or all the strategies we talked about, I'm gonna snip in the answers. You'll find that sometimes they work, and sometimes like they kind of work, or you guess a little bit. So here are the answers. So that's square root of 20 part. You got to figure out, well, which of these is it? Is it the 5? Does square root of 20 become 5, or does it become 13?
Square root of 5.
Yes. So that means you can eliminate 2 of the answers. And again, notice I'm not like if we were doing this in an algebra 2 class, be like, just do the formula. But like, because there's answers, we want to figure out which ones can be eliminated. Now, just like in the previous problem, you use the b value to differentiate.
It's
Sorry.
positive.
So the b is positive, but you negate the b in the formula. Minus b
So,
plus or minus. Your b is 6, so you negate it.
so it would be -3.
Yeah.
Okay.
Okay, so I may have you try one on your own here. This one's about as straightforward as it can get with quadratic formula. This one you actually do need to solve. Sorry, just a little lag there on the Zoom. So this one says, what are the solutions to 3x squared plus 12x plus 6 equals 0? Now, before you do the quadratic formula on this, and one reason you might know to do the quadratic formula is because of all the square roots, is you can eliminate the greatest common factor. Basically, you can divide everything by 3. And that will save you a bunch of time here for this problem.
Okay.
So I'd like you to use the quadratic formula from this part forward. I will write it down here, minus b plus or minus the square root, b squared minus 4ac all over 2a. And go ahead and take a look at that and see what you come up with, please.
Is it the square root of 2?
So I want you to do everything for this one. Yeah, that seems most reasonable to me. Your b value though is 4, right? Minus 4
Mm-hmm.
plus or minus, and then it's b squared minus 4ac, which is, what did you end up getting for that part?
I got as far as the square root of 8 over 2.
Yes. Okay. So now you do have to reduce the square root of 8.
Mm-hmm.
Square root of 8 is 2 and 4, 2 and 2. So you bring a 2 out. So it's minus 4 plus or minus 2 square root of 2 over 2. And you end up having to divide both of these by 2. So that's a minus 2 plus or minus square root 2.
Okay.
Any questions on that?
No.
Okay, we're gonna look at a couple more of these. I know these aren't super interesting, but you do get some, you do get, I'll say two quadratic formula type questions on this. So we just need to keep hammering away here for this. All right, so this one looks really bad. Would you kind of agree with that?
Yes.
Okay, I mean, it's just one of those things you're like, oh my gosh, this looks horrible. So a couple of things here. It's not in standard form. You have to move the 2p over for this. Like this. Another thing is that you generally get rid of any fractions. What would you multiply everything by to get rid of fractions?
2.
2. So that gives you 2x squared minus kx minus 4p equals 0. Now, again, it's ax squared plus bx plus c equals 0. What is the value of a, b, and c in this?
A is 2.
Okay.
B is -1 and C is -4.
B is negative k.
Negative K.
Yes, it can be a letter, but it just can't be the variable.
Okay.
So what about C? What is that? Because it's more than -4.
-4p.
Yes. Okay, we won't go any further on this question, just because I think it'll be very confusing, but I did want you to kind of see that possibility here, because it leads us into the next type of question you'll see. So
Okay.
now, do you remember what the part under the square root is called? What name was given to that?
I don't remember.
It's called the discriminant. Now, why is it called that? I have no idea. I couldn't tell you, but that's what it's called. So the discriminant is, there's three possibilities. It's usually referred to as D equals B squared minus 4AC. There's three possibilities. If D is greater than 0, it has two positive solutions. This is just review. You've seen this before. This is the one you have to pay attention to. If D equals 0, there is one solution. And you're like, why is that? Well, if B squared minus 4AC is 0, this becomes minus B plus or minus the square root of 0 over 2A. The square root of 0 is 0, and it just becomes minus B over 2A. But this is the big one. This is the one you really need to commit to memory.
Okay.
Okay. Because like most things I do, I'm very predictable. I give you a problem now where that is part of it. All right. So let me show you that. All right. In the given equation, C is a constant. Okay. C is a constant. They're saying it's a number, but they don't know what it is. If the equation has exactly one solution, hey, that means the discriminant B squared minus 4AC has to equal what value if it has one solution?
0.
0. Yeah. So notice you don't care about the rest of the formula, you just care about this part of it. So can you tell me the value of A, B, and C in this formula?
Yes.
What is the value of A?
A is 1.
Okay. B is,
B is -2. And
C is
C
just
is
C.
just C. Okay.
Okay. So you're going to put those into this formula. So B is -2. A is 1 and C is C. You have to solve this, solve for C.
Does C equal 1?
Yes. Very good. Any questions on that?
No, I don't think so.
Okay. So this one's a little bit weird again, but we'll look at it together. Kind of going down the same path here. Okay, so this is the start of a new question. It's given as 2x squared minus 4x equals t. My question to you is first is this in standard form?
Yes.
So standard form is ax squared plus bx plus c equals 0.
Oh, then no.
Okay, so what do you need to do to make it in standard form? What would you move?
move the t and set it to
Yes.
0?
Yes, so 2x squared minus 4x minus t equals 0. Can you tell me the values of a, b, and c in this equation, please?
A is 2, B is -4, and C is negative t.
Yes. Very good. Okay, now I want you to calculate b squared minus 4ac for me, please.
It's 8 times negative t.
What about this b squared part? Did you substitute in b as -4
Yeah,
like this?
yes.
Okay, so it's 16 minus, but the minus becomes a plus because there's two negatives there, 8t. I heard something different. That's why I'm asking or going through this.
Oh, okay.
So let's say you wanted it to have one real solution. What does the discriminant have to equal?
It has to equal 0.
Yes. Could you solve this for t?
-2.
Yes. Very good. Okay, so last kind of, the short time we've got left, last kind of a thought here is let's just say you solve using the quadratic equation and you got the following. You got -4 plus square root of 3 and -4 minus the square root of 3. Okay, and I said I want you to add the solutions together. So it's -4 plus square root of 3 plus -4 minus square root of 3. What do these add up to? Or maybe a better question is what cancels?
The -4.
These two right here?
Yes.
They're the same sign though. Same sign, don't cancel. When
Oh,
they're
okay.
opposite in
Oh,
sign,
cancel.
yeah,
Okay.
cancel. Sorry if I
So,
slurred my
so
words.
square root of 3.
Yes. So the answer is this becomes -8. That's interesting. Let's look at another one here. Let's say it's you get -2 plus square root of 5 -2 minus square root of 5. What is the sum of the answers?
-4.
-4. That's interesting. So where it gets really interesting is when you have like a fraction. So let's say it's like -3/2 plus square root of 5 over 2, comma, -3/2 minus square root of 5 over 2. What do these add up to? What do the solutions add up to?
-6 over 2.
-6 over 2, which is really -3. So there's a pattern here, right? It's just these two. Okay, so the if you recall, the quadratic formula is -b over the 2a. That's what this part is. So you end up basically doubling -b over 2a to get your answer.
Okay.
Okay. so why is that important? Well, let's look at a new question here to answer that question. So let me so you saw that the square roots canceled in all these questions, right? So let me snip in the answers. Which can it not be? Which answers can we exclude right away? So let me go back and show you. Did our answers have a square root in it in this problem?
No.
After we added them, did our answers have a square root after we added them in this problem?
No.
No.
Okay.
So it's the ones when it says the sum of all the values of them, that's the solutions. You're like, hey, it can't be those two. Okay.
Yeah.
But let's work through this one like we've been doing with the others. Let's divide everything by 2. So that's m squared minus 8m plus 4 equals 0. And we want to use the quadratic formula here. So a equals 1, b equals minus 8, and c equals 4. So it's your formula is minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to start substituting numbers. Okay, so it becomes minus 8 plus or minus. Now, we actually do not care what's in the square root. I know we want to write it out, but we actually don't care what it is because it ends up canceling in the end anyway.
Okay.
We will write it. But we want to focus on this part out in front here. Can you tell me what that reduces to?
4.
Yeah. So our answer is 4 plus or minus the square root of whatever that is inside there, which ends up, 64 minus 16. It's not that bad. It's 48 over 2, but it's 4 plus the square root of 48 over 2, 4 minus the square root of 48 over 2. When you add those up, what do they combine to?
8.
8. So that's how you do it. So that what I was trying to show you here is the shortcut when you're adding quadratic solutions is that it's always a whole number. And that might save you, you're down to guessing between 2, or you can work it out to figure out the answer.
Okay.
All right, Julia, that's it for us for tonight. Thank you for letting me help you, and see you again whenever you schedule. Hope you have a great rest of your week, but I've got availability if you want to get another lesson in before for your exam.
Okay. Thank you so much.
You're welcome. Bye now.
Bye.